In the last chapter, we worked on how to instantiate a tap gesture recognizer in our app. Once you go through this process a few times, you'll be able to do it on your own with your eyes closed. Programming is all about repetition. The more that you do something, the better you get at it, and computer programming is a perfect example of this. We left off where our app is able to snap pictures and have them show up on our UI in the UI image view that we configured on our user interface. There are so many apps on the App Store that use a camera, and if you didn't know how to incorporate a camera into an app before, then you know how to do it now. So congratulations on that. In this chapter, we are going to explore how we tie in a pre-made trained Core ML model. We are now going to join images and machine learning together with the Core ML framework provided by Apple in iOS 11. We will be able to see the best prediction and how confident a model is on the accuracy of what we are feeding to the model through the camera. So let's open up Safari and go get us a model from the Apple developer site. Okay, so we're over at the Apple developer portal on the machine learning page. And what we're going to do is we're going to explore some of our options. Here's a little bit of a brief overview as to what you can do with Core ML. Core ML lets you integrate a broad variety of machine learning model types into your app. The Vision framework is a framework that we're going to use in this app. Pretty important to understand what's going on inside of it, and so on and so forth. So these are the models here that we can choose from. We're going to be using the SqueezeNet model. All you have to do is download the Core ML model. It'll show up here in your downloads, and it is the SqueezeNet.ml model. Once we have a model downloaded, we have to import it into our Xcode project. We actually take the file that has the .ml model suffix and drag it into the folder hierarchy, or what Apple refers to as the project navigator. A few things to verify are: 1, check the box, copy items if needed. 2, make sure the bullet with the create groups is chosen. And 3, add to targets should also have a check. So after we add the model to our Xcode project, you can highlight it, and we can see some information about the model, including the model type and its expected inputs and outputs. For the SqueezeNet model, the inputs are an image, as you can see here in the type, and the output is of type string, and this string represents the category that the image is most closely linked to. So we want to make sure that target membership is clicked. And after we click it, you'll see a Swift generated interface for the model. Now you can click on the little arrow here to go and explore the actual machine learning model. It's basically a class that's set up just like any other class inside of Swift. You should explore the model class to see how Apple engineers write functions and classes. This is another great way to learn. Okay, so at this point, we're going to scroll up to the top of our class and import the 2 frameworks that we're going to be working with: Core ML and Vision. Core ML basically handles all the machine learning stuff, and Vision handles facial recognition, object recognition, stuff like that. Core ML basically allows us as developers to embed machine learning capabilities inside our apps. With these capabilities, our apps can identify real-world objects in real time. Let's scroll further down in our class, main VC. So right under the line here, photo data equals photo.file data representation, is where we are going to start incorporating our machine learning model. The thought process behind this is because we are inside the function where we are physically taking the picture with the device. The OnTap Cam View function is where the magic happens for the user of the app. The way we start manipulating our model is by setting up a do catch block. We've done this before. We're doing it again because when we use Vision, it can throw errors. So we're going to type let model equal try VN Core ML model. The VN Core ML model is a container for a Core ML model, and it is used with Vision requests. So in this line, we type let model equal try, and we are using try because VN Core ML model can throw errors. The compiler needs to catch up. Autocomplete lets us know that VN Core ML model throws errors. You see this visually by what it auto-populates for us. In this line, we are basically saying that we have a model, which in this case is the SqueezeNet model, and we are passing it through vision so that we can identify what is inside the image we have snapped. So in the next line, we're going to be making the request. So it's let request equal vn core-ml request. A vn core-ml request is an image analysis request that uses a core-ml model to process images. We're going to choose the option with the completion handler because that is where we will handle the response we get back from this request. Think of a completion handler as a spot in our code to do something once something else is done. It is, of course, more complicated than that, but that's a topic for us to cover in and of itself. Xcode is complaining about errors thrown not being handled. So let's take care of that now by finishing our do-catch block. We now scroll up and create a function so that we can call that function from our completion handler before we fill in the above functionality. So let's scroll up, and right above our function on TapCam view is where we'll set this up. So let's type func, and we'll call this res method. And we're going to set it up with a few arguments. The error argument is an optional because there's not always an error thrown. It's basically saying in case there is an error or an error is thrown, let's handle it here. Let's come back down here to our do catch block. Our model is basically the model from the line above. And now we can fill in our completion handler. The function above is the code that will be called at this point inside this completion handler. We do not have to fill in any of the parameters inside the results method function when we call it from our completion handler. Reason being is that when making a request using Vision, it is built in as a default. I know this may be a bit confusing if you're seeing it for the first time, but look at it as the error is being handled when necessary by vn core-ml request internally. Okay, so the handler is basically going to take the request and turn it into something that we can use. So we type let handler equal vn image request handler. The vn represents the Vision framework. Remember, autocomplete is your friend. It is letting us know the definition right on the screen for what a vn image request handler actually is. There are a bunch of choices here, and we want to choose the option with data here because our image is represented in a data state. We don't need the options in this case, and we're going to pass in our photo data from above. Xcode is complaining about something. We will address that in a second. Autocomplete is not cooperating again. What does that tell you? Okay, so we have something going on here. What's going on in the try? Okay. I did not unwrap photo data in the line above. So Xcode is complaining. Let's unwrap photo data. And now autocomplete should work. So it's try handler. Dot perform. And notice that the handler can take in an array of Vision requests. Next, we want to fill in our portion of the catch statement with debug print so we can see any errors thrown displayed in our console. So we're at a good point to stop and review. So in this chapter, we basically downloaded a trained core-ML model. We imported into our project navigator. We explored the options that we can use inside the SqueezeNet model. And we also started writing the code to show how we manipulate our model once we have it imported into our Xcode project.